Might be a little blurry. I don't know.
It's pretty good. Better than my normal, actually. All right, where do you want to start?
I think I know how to do the first one. So.
Okay. But the second one?
For each polynomial completely. Don't you just do the like it's -7 and 7?
Yeah, but it's important to understand what you're looking at. That is the difference of perfect squares.
Oh, okay.
In other words, if you have the difference of perfect squares, it always factors into a minus b times a plus b. So in this particular case, a is x, b is 7. So you have x squared minus 7 squared. That's the difference of perfect squares. It's going to go into x minus 7 times x plus 7.
Okay.
And that's actually the answer. That's the complete answer. They don't actually have an equation here, so they don't ask you to solve for anything. They just want you to factor that expression. And the fact,
Okay.
because it's the difference of perfect squares, it factors into that. Okay.
Okay.
Number 13. First of all, let me write the order that you want to look. First of all, you want to check for any greatest common factors. Second, you want to check for difference of perfect squares. Third, you want to check if you can factor it as a quadratic. And if none of those work, fourth, you use the quadratic formula. So let's take the first step. Always go in this priority. Is there a greatest common factor that comes out of that?
3, I think.
Well, what's the greatest number? Let's start with each variable. What's the greatest number that factors out of both of those things? And by that I mean, what's the greatest number that divides evenly into 12 and 6?
Wouldn't it be, wait, no, 6, I think?
6. Yeah, it's not 3, it's 6. When I say the greatest, well, 6 is bigger than 3, and 6 does factor out of that. So let's do it 2 steps at a time. In other words, after you factor out a 6, this is what you have left. And always in math, always, in your mind, do the check. In other words, does 6 multiplied by that equal what we started with? It sure does, because you got 12x cubed, y cubed, plus 6, x squared, y squared. That's what we started with. So when I say do the check, always perform that check.
Okay.
Now, is there a variable we can take out? So all we dealt with was the number. How about let's look at the x. Is there any x that we can take out?
You can take out 1x.
You can take out x squared.
Yeah.
By 1x, I meant what's the greatest x we could take out? Well, It's x squared. What's left behind? You tell me.
The 2x cubed. And then the y cubed. And then plus y squared.
Okay. Now multiplying it back together, do we get our original function?
Yes.
I believe we do, yes. Okay, now let's look at the y. What's the biggest y we can take out?
The 2. No, the cubed.
No, you were right. Y squared. Okay. Remember what greatest common factor means. Greatest common factor means what is the biggest thing that divides evenly into that term and that term? And it's only y squared. It's not y cubed. Y cubed does not divide into y squared evenly.
Okay.
Y squared does divide into both y cubed and y squared evenly. So what we're left with here is xy plus 1. Now, do the check. Multiply it together again. Do you still have that? Yes, looks like you do. And now we have fully factored it. Factor each polynomial completely. There is no more factoring we can do. But this is an excellent problem for making sure you do it in this order. Always look for greatest common factor first.
Okay.
All right, how about this one? Is there a greatest common factor? Here's the order. We look for greatest common factor, and then we look for dopes. What's dopes stand for?
Perfect square.
Right, difference of perfect squares. And then we look for a standard quadratic where we can factor it. And then if we can't do any of these three, then we got to use the quadratic formula. Well, on number 4, is there a greatest common factor?
Isn't it 7?
Nope. There is no greatest common factor of 7. I cannot divide x squared by 7 and have it come out to be even. It's not a whole number.
Greatest common factor of 49.
There isn't any.
Yeah.
How about dopes? Is this difference of perfect squares?
No.
Is that a perfect square?
Yes.
Is that a perfect square? Are they being subtracted?
Yes.
Then you have difference of perfect squares. What is it?
Difference of perfect squares.
It's always x minus the square root of that times x plus that.
Oh, and then you just add the
So the primary thing is to see that that is a perfect square number, and the square root is 7. In other words, if I have a squared minus b squared, that's always equal to a minus b times a plus b. And that's what we've done, is we've separated x squared minus 49 into a minus b times a plus b. Okay. About number 5. Oh, we have difference of perfect cubes, and we probably have the sum of perfect cubes. I didn't know you'd gotten that far. but that is definitely the difference of perfect cubes. So
Okay.
what you need to know here is that a cubed minus b cubed is equal to a minus b times a squared plus ab. The plus is always opposite this sign, plus b squared. Okay? So I didn't realize you had gotten to difference of perfect cubes, but that's what that is. What's the perfect cube that is 216? What's b?
What's what?
What is b? In other words, if this is indeed the difference of perfect cubes, well, I know that a is x, but what's b? What's the cube root of 216? Always know it's going to be a whole number and it's going to be a small whole number.
Wait, how do I figure that? I don't know.
Well, it's either going to be 2, 3, 4, 5, or 6. 6 is the only one that makes any sense because 6 times 6 ends in 6. 6 times 36 ends in 6. So one way to figure out cube roots is to know that fact. In other words, let me just give you this because not everybody realizes this. If I square 14, what's the last digit going to be?
4
6.
or 6?
4 times 4 is 16.
Mm.
So that's key. Well, in this case, I'm saying that 6 times 6, that ends in a 6. And then I'm going to multiply it by 6 again. That ends in a 6. So the fact that I see that this ends in a 6 tells me a lot of information. It means it can't be 5 cubed. It can't be 4 cubed. It can't be 3 cubed. It can't be 2 cubed. It can be 6 cubed because 6 times 6 always ends in a 6.
Okay.
Not super important math to know, but helpful sometimes. Just knowing that kind of stuff. So, A is X, B is 6. So what this really is A cubed minus 6 cubed. Now, use that formula to factor it. What's A minus B?
X minus 6.
Good. What's the rest of it? It's A squared.
A squared. It would just be x squared.
Keep going.
X squared plus 6 times x. Plus I mean 6x. And then plus b squared. Oh wait, no, plus 6 squared.
Which is 36. So there's your answer. Okay. Now, solve each equation. So if I get that that's equal to 0, what's the solution? What's my next step? If x minus 6 times this quadratic is equal to 0, I'm trying to solve for x.
Wouldn't you get x cubed? Wouldn't you have to factor it?
No, you've just factored it already. You don't want to multiply it back together again and get back to where you were. That will not help things. But this does give you an answer. Don't forget your first principle of algebra. If you have two things multiplied together that equals 0, one of them has to be 0.
Mm-hmm.
So you set x minus 6 equal to 0. What solution does that give you?
6.
Okay. And then if you set the other one equal to 0, it doesn't take long before you realize that that is a complex solution
Yeah.
involving I. In fact, you cannot factor that. You have to use the quadratic formula to solve that.
Okay.
And so if we're really going to solve this number 5 here, one solution is x equals 6. And we can certainly see that. 6 cubed is 216. 216 minus 216 is equal to 0. So x equals 6 is definitely one solution. Have you had complex numbers, Haley?
Yeah.
Okay. Well, when you go to solve that one, you got to use the quadratic formula. And when you use the quadratic formula, you're going to get complex solutions. Do you know the quadratic formula?
Yes, but I cannot remember it.
Well, then you don't know it. When I say do you know it, I mean from memory, not do you have to look it up. Okay? It's
Okay.
useful to memorize this. You don't want to have to look it up all the time. You're going to be tested on this. You were tested on it in the SAT. Was there not at least one question in that that required you to know the quadratic formula?
Yeah.
Okay. So you want to know it. Whatever you got to do to memorize this, do it. I wish I had the song that they teach some students. I don't. I know that that is one way it's taught. Songs are great for teaching stuff. I don't think I would know my ABCs if I couldn't sing them. A, B, C, D, E, F, G. If I couldn't do that, I'm not sure I could tell you which came first, I or J or H.
Mm-hmm.
Whenever anybody asks me that, I got to go back and sing it. So sometimes songs are extremely valuable for memorizing things. Now, I've had at least 10 students sing me the song for memorizing this. And I still can't remember it. It's something like x equals minus b plus or minus square root b squared minus 4ac all over 2a. It's something like that. But that's not it. But whatever it takes, you got to memorize this. Just something you got to do if you want to succeed in math.
Okay.
Okay? All right, let's look at number 6. First thing you look for is what?
Where'd it go? The greatest common factor.
Is there one here?
No.
How about variables? They're a variable greatest common factor.
Yeah.
What is it?
The 2?
Can you divide every term by 2?
No.
What can you divide every term by?
X.
That's it. That's the greatest common factor. Remember, you always have to be able to divide every term by it. So when you divide every term by x, what do you get inside the parentheses?
If you divide it, the X.
When you factor out a greatest common factor, what you are doing is dividing every single term by that. So what is x cubed divided by x?
X squared, I think.
What is x squared divided by x?
X.
What is minus 2x divided by x?
Just X, I think. I'm not sure how to.
Now, before you do the next step, the secret of math is always to check your answer. In other words, if I multiply x times this quadratic, do I get what I started with? Do it and tell me if you get what you started with.
Yeah.
Okay, then we've done it correctly. Now, can I factor that?
Yes.
Okay, into what?
Into. So you. What is it? It's. Okay, hold on.
First step is split up the x squared. First of all, forget this leading x. Just set that aside. That is not the problem. The problem is, how do we factor x squared plus x minus 2? That's the problem.
Would
So
you do
how do
X
we factor that?
X plus 2?
Well, I'm not sure I've ever taught you my method for factoring. I'm just going to go through it. I hate the method that they teach you in school called the California method or the diamond method. I just hate it. I refuse to teach it to students. This is a really easy. That's why I refuse to teach it, because my method is 10 times easier than their method. So the first thing you do is split up the x squared. Well, it's got to be x times x, right? That equals x squared. Second thing you do is determine both signs. Well, what we're doing is FOIL backwards. So the only way I can possibly produce a negative 2 is if my signs are opposite. They cannot be the same. If they were both plus, that would be a plus. If they were both minus, that would be a plus. So the fact that that's a negative 2 tells me my signs are absolutely opposite one another. And it doesn't matter whether I put plus minus or minus plus.
Okay.
Now, third step, factors of 2.
1, 2.
That's it.
Yeah.
So either it's 2 and 1, or the other way around. It's 1 and 2. Now, how do we tell if this is correct? My first guess. You do what I call the double smiley face. In other words, figure out what your O and your I of FOIL are. Well, the inside is 2x. The outside is minus 1 times x minus 1x. Add them together, you get plus 1x. Is that our middle term?
Mm-hmm.
That means we did it right.
Okay.
That is the complete process. We attempt it. We see if we got the middle term right. If we did, we're done. Now, we're not quite done. They want to solve each equation. So we got to still solve this. We got to come up with the values of x that make this an equation. Well, what are they? We're down to this step right here.
Wouldn't doesn't
What
one have
values of x make that equation true? And there are more than one.
1?
Yep, that's one of them. Because that makes that 0. And whenever you have 3 numbers and one of them 0, the result is always 0. What's another one?
-2, I think.
That makes that 0. So that would be true. What's the third one? And this is the one most students miss. They don't think of it.
Would just be 0.
That's it. Because that needs to be 0. So if x were either 1, -2, or 0, this number 6 would be true.
Okay.
Any of those three values, if you substitute any of those three values for x, you will see that you have an equation in all three cases.
Okay.
All right, we got 5 minutes. Let's talk about something different but easier. What's the answer on 7?
Don't you just have to subtract it, so that would be 2x cubed, so 7.
Well, first of all, how many x? Okay, you're right. There's only one x cubed, right?
Yeah.
Okay, so that's in the answer.
2x
About
cubed.
x squared. So we got a minus 4x squared there. And what's that?
11x cubed.
Squared.
Yeah, squared.
Okay. Now, how about the x's? How many total x's do we have?
Minus 3x.
No, you got to apply that negative sign to every term that's in the parentheses.
Also, it'd be plus 3x.
That's right. And how about the number?
13.
Correct. That's your answer. The only difficult part of this entire problem is when you see a negative sign like that, then do what I suggest everybody do. Turn it into an addition problem. Well, for me to turn it into an addition problem, I got to do that. Then I got to change the sign of everything that was being subtracted. So I got to make that a minus 7x squared plus 3x plus 4. And now I can remove the parentheses, all of them, and then just combine like terms. So whenever you have a negative sign like that, number 9, make sure that that negative sign gets applied to every term in the parentheses. That's the secret. If it's a plus sign, like this, number 8, then I can just remove the parentheses immediately, both of them, without doing anything. In other words, that's the same thing as 2x cubed minus 4x squared plus 9 plus 5x squared minus 3x plus 4. In other words, when you have addition going on, you don't need the first set of parentheses. You never need the first set of parentheses. But I can just remove the second set without worrying about anything. Now simplify that. How many total x cubes do you have?
2.
How many x squareds do you have?
1.
How many x's do you have?
That'd be 3x, I think. Yeah.
Minus 3x.
Minus 3.
How many numbers do you have?
2, so it'd be 13.
There's your answer. So the key to these problems is whether addition or subtraction is going on. Notice that subtraction, I got a lot of work to do to remove these parentheses. Addition, I don't have any. When I'm adding two polynomials, I can just remove the parentheses and go to work. So number 9, going to be what?
3x cubed. And then minus 7x cubed.
Minus 7x squared.
And then 3x.
Give me a sign. When I'm writing a polynomial, I got to have a sign in front. If I just write 3x, it has no meaning. I got to have a plus or minus in front of it because it's part of a polynomial. The only reason I don't need a plus or minus in front of that is because it's the very first term. That's it. If it's not the very first term, then you got to have a plus or minus in front of it.
Okay. It'd be plus 3x. And then plus 5.
Good. There you go. Okay. Now I got a problem. I got a 4 o'clock session, so I'm going to have to go.
Okay.
I'll keep note of where we left off, and I'll talk to you next time.
Okay, thank you.
You're welcome. Bye-bye.
Bye.